Okay, let's dive right into this. Welcome to today's Explainer, where we are going to completely decode the complex and honestly fascinating mechanisms of digital money. For centuries, our concept of value has been firmly tied to physical things: gold, silver, paper bills you can hold in your hand. But over the last 2 decades, this radical shift has occurred. Today, we're going to break down exactly how invisible digital tokens hold immense real-world value, and we'll do it by looking really closely at the engine running just beneath the surface. Here is our quick roadmap for today. First, the spark of cryptocurrency. Second, the engine of trust. Third, leading digital currencies. Fourth, the decentralized exchange. And finally, number 5, the architecture of value.
So, think about this for a second. What if money didn't actually need a central bank to be trusted? Historically, money has literally always relied on a trusted third party, a king, a government, a massive central bank, to guarantee its worth and process every transaction. But what if the decentralized network could just step in and do that exact job securely, instantly, and globally? Well, this is the fundamental problem that decentralized digital networks set out to solve.
Let's start with Section 1, the spark of cryptocurrency. To really understand how we got here, we got to rewind back to the financial landscape of 2008. That year was an absolute watershed moment. Under the pseudonym Satoshi Nakamoto, a brilliant proposal for Bitcoin was published, and the very first blockchain was implemented. Now, this was revolutionary because it used cryptography to solve a massive technical hurdle known as the double spending problem. Think about it. Before this, if you had a digital dollar, what was stopping you from just copying and pasting the file and spending it twice? Nakamoto's solution was a trustless, tamper-resistant distributed ledger. Literally no central server was needed to verify the transaction. And today, as you know, this single spark has exploded into an ecosystem of thousands of cryptocurrencies.
Moving on to Section 2, the engine of trust.
So how exactly does a network of complete strangers actually agree on who owns what without some central authority stepping in? Well, think of a blockchain as a decentralized state machine. Step 1, a user broadcasts a transaction out to the network. Step 2 is really where the magic happens. The network validates it using a consensus protocol via cryptographic proofs. So instead of a bank manager verifying your account, distributed nodes check the entire ledger's history for accuracy. Step 3. If the majority consensus agrees it's completely valid, the transaction is permanently recorded in a block. And Step 4, the state of the chain is updated across all nodes globally. Essentially, decentralization plus consensus equals trust. But how exactly do these networks reach that consensus?
These networks actually rely on 3 main algorithmic engines. First up, we have proof of work, or POW. Here, miners basically race to solve complex mathematical puzzles using massive computational power. It is a highly secure process because altering the record would require just an overwhelming computational force, but it famously consumes more electricity than some small countries. Next is proof of stake, or POS. Instead of doing brute force puzzles, validators are chosen based on the collateral they lock up, meaning the cryptocurrency they stake in the network. Those with the most skin in the game get to propose and approve blocks. It's incredibly energy efficient and scalable while still maintaining robust security. And finally, there's proof of authority, or POA. This one is often used in private enterprise networks. Here, a small group of trusted, pre-approved administrators validate the transactions. It's wildly fast and efficient, but it does trade away absolute decentralization to achieve that speed.
All right, Section 3, leading digital currencies. Understanding these 3 giants and their underlying mechanics is absolutely crucial to grasping their real-world impact. First is Bitcoin, the pioneer. It relies on that highly secure, energy-intensive proof-of-work model we just talked about and is often viewed by the broader market basically as digital gold. Then we have Ethereum, which executed this massive technical feat by actually transitioning its live network over to proof-of-stake. They did this to drastically reduce energy consumption and improve scalability for its vast ecosystem of smart contracts. Finally, we have Ripple, specifically utilizing the XRP ledger. Now, rather than focusing just on being a store of value, it focuses heavily on cross-border payments and on-demand liquidity.
Which brings us to Section 4, the decentralized exchange.
So the crucial point here is the stark structural difference between traditional and decentralized networks. Take SWIFT, for example, the legacy messaging network connecting over 11,500 banks worldwide. SWIFT doesn't actually move money, it just sends secure messages. To facilitate international transfers, banks actually have to tie up billions of dollars in pre-funded Nostro and Vostro accounts all around the world. It's a very reliable, deeply established corresponding banking system. But contrast that with a blockchain-based based approach like Ripple's on-demand liquidity. By using the XRP token as a bridge asset, it attempts to bypass those correspondent relationships entirely. Instead of holding pre-funded capital in destination currencies, the system sources liquidity dynamically at the exact moment of payment. And look, we aren't looking at this to say one is universally better than the other. Rather, they are entirely different structural architectures solving the exact same problem of global exchange.
I mean, just look at that number. 3 to 5 seconds. That is the actual settlement speed on the XRP ledger. At the blockchain level, the digital asset leg of a transaction can settle almost instantly for literal fractions of a cent. However, it is super vital to note that end-to-end payment speed for consumers or businesses still heavily relies on the traditional fiat rails at the endpoints. The value still has to navigate local compliance checks, exchange execution, and local payout partners. But that core digital transmission across borders, it literally happens in mere seconds.
And finally, Section 5, the architecture of value. So if these coins are just lines of code settling in seconds, why on earth are they worth anything at all? Well, quote, the architecture of value is no longer defined by physical commodities, but by the strength of the networks, both social and digital, that define and verify obligation. What this profound insight from the source material tells us is that money, whether it's an ancient clay tablet recording grain debt in Mesopotamia, a printed dollar bill, or a digital Bitcoin, is ultimately just a ledger of trust. Its value is derived entirely from the consensus of the network using it. Let's break that down. Fiat money derives its value from government decree and centralized trust. I mean, it hasn't been backed by gold for decades. Cryptocurrency, on the other hand, derives its value from network consensus, mathematically enforced scarcity, and raw market dynamics. Because the supply is strictly regulated by code, a cryptocurrency's price is relentlessly dictated by global supply and demand in real time. Both systems are impartially reliant on human trust. They just build and price that trust using entirely different architectures.
Now, what's really interesting about this slide is how economic theory dictates that a state can take a totally useless token, like a piece of paper or a base metal, and literally force it to circulate as money by establishing it as the exclusive medium of exchange in specific trading zones. Think about paying your taxes. You have to use the state's currency. This is the pure bootstrap nature of a fiat system. It works because the centralized state mandates it. Cryptocurrency transcends this need for state-mandated bootstrapping. It achieves circulation and value completely organically through a decentralized network of participants voluntarily agreeing on the validity of the ledger.
Which brings us to our final thought for today. Code is the new gold. Are we ready for the future of money? We've traced the incredible journey from Satoshi Nakamoto's 2008 Spark right through the algorithmic engines of proof of work and proof of stake, all the way to the global decentralized highways moving value in mere seconds. The architecture of money has fundamentally shifted from physical commodities to state-issued fiat to decentralized digital consensus governed by real-time market dynamics. The rules of finance are quite literally being rewritten in code. Thank you so much for joining me on this explainer. Keep asking those big questions, keep exploring the data, and I'll see you next time.